Imagine a colossal symphony played by a boundless number of stars, planets, and moons, all proceeding as a bound-together opening. At any rate, there is one explicit area of this group that has baffled cosmologists for a seriously prolonged stretch of time. Exoplanets are typical planets that exist outside our planetary gathering, hid away somewhere down in the Milky Way. You might be surprised to find that among the huge number of galactic objects, there are exoplanets so like Earth, so the story goes off in an unexpected direction, particularly like in any science fiction roller coaster. Experts using the James Webb Space Telescope found something amazing from Proxima b, a signal so weird that it moved all through the educational sections and casual networks. It was named a potential technosignature. It was an electromagnetic spread so perplexing and enormously planned that it would be able to show the presence of a high-level progress. The joint heartbeat of mankind seemed to stop at the pinnacle of a disclosure that vowed to change our perspective on reality. Might the signal at any point be the certain proof that we are not alone in the universe? And likewise, as quickly as it appeared, the signal evaporated without repeating itself, leaving behind not simply an overwhelming quietness, but also a maze of unanswered questions and permeating theories. Was it simply a transient, incalculable characteristic, a mishap of gaudy course of action, or something more deliberate, a coded message or even a signal of an upsetting, incalculable core? The solitary mission cast a sad remnant of problem over Proxima b, beginning a limit conversation in principle. Was it basically a passing inconsistency? Or is it part of an endless record, obviously more baffling than we can imagine? Anyway, stand by. The record, a weaved work of art of our boundless examination, isn't complete. The ink has not yet dried, and new segments are still being made. This time, it isn't just norm scientists, but Harvard experts who are driving an adjustment of perspective in our search for extraterrestrial life. They are not aimed simply at analyzing the signs and characteristics we have studied up until this point. They are expanding the game by changing the James Webb Space Telescope into a sort of huge evening vision telescope. They want to search for artificial light sources in both the faint and illuminated areas of distant worlds. We're checking out ideas, for instance, the possibility of distinguishing natural variations of metropolitan regions shimmering in lack of definition, like brilliant SPS. Imagine seeing the brilliant shafts of what could be a city, mumbling with the presence of a high-level progress, exuding its gleam into the huge, self-important oceans. As we continue to unravel the secrets of the universe, the journey for extraterrestrial life takes on new perspectives. Beyond the brief interest in Proxima b, our huge chase plunges further into the colossal, unusual areas of space. This pursuit is driven by both creative advancements and a huge interest in our spot in the universe. Continuous advancements in cosmology and space exploration have prompted the discovery of different exoplanets with potential habitability. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have extended our ability to recognize and analyze these distant worlds. One particularly interesting field of study is the search for biosignatures of life. Biosignature imprints could include atmospheric gases like methane or carbon dioxide, which, in the right conditions, could suggest biological cycles. The JWST's capacities connect beyond basic discovery. Its high-level instruments can measure the atmospheric composition of exoplanets with excellent precision. By exploring starlight that channels through an exoplanet's atmosphere, specialists can recognize chemical marks typical of life. For instance, the presence of water vapor, along with other key molecules like oxygen or ozone, could indicate the potential for life-supporting conditions. Another avenue of investigation involves analyzing the conditions of these distant worlds. Environmental models, other than the possibility of technomarks, have gained traction. These are indications of advanced civilizations that might be detectable through artificial structures or advanced technology. This could include megastructures like Dyson spheres, speculative builds designed to capture a star's energy, or surprising patterns in radio transmissions. As we advance our observational techniques, the search for technomarks could uncover the presence of extraterrestrial intelligence. Notwithstanding imaginative movements, global joint efforts are essential in the quest for extraterrestrial life. Collaborations between space agencies, research foundations, and private affiliations enhance our ability to explore space. For instance, missions to Mars and other celestial bodies incorporate contributions from various countries, pooling resources and expertise to achieve shared objectives. Public engagement and education play crucial roles in this journey, and the energy surrounding space exploration spurs the future of scientists and experts. Effort programs and educational drives help to cultivate an interest in STEM fields and urge adolescents to pursue careers in space science. The advancement of new technologies also adds to how we may understand the universe. Advances in telescope design, data processing, and computational models improve our ability to recognize and analyze faraway exoplanets. For instance, cutting-edge space telescopes like the Very Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABEX, promise to offer significantly more detailed observations and deeper insights into the potential habitability of exoplanets. As we push the furthest reaches of our knowledge, each discovery prompts new questions and areas for exploration. The search for extraterrestrial life isn't just about finding alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our perception and expands how we might interpret what it means to be alive. The exploration of exoplanets and the search for extraterrestrial life are dynamic and evolving fields. With each step, we edge closer to answering some of the most important questions humanity has ever asked. As we continue to explore the universe, the opportunities for finding new forms of life and understanding our place in the cosmos remain endless, tantalizingly similar yet bafflingly different. It might be our planet's heavenly twin. We dive into the fascinating area of Proxima b, found just 4.2 light-years away. The James Webb Space Telescope is shaping our journey for an understanding of these celestial puzzles. Imagine a moment when your mind travels across the vast, grandiose space of our galaxy, the Milky Way, which is home to more than a quadrillion exoplanets. That's one followed by 15 zeros. To put this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't just fill the Grand Canyon, we would have enough to create another landmark on Earth. A Grand Canyon 2.0 that would extend for a huge distance. What is most surprising is that around 20% of these celestial bodies have been deemed Earth-like in terms of geological and environmental design. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, rough satellites like our moon, engaged in gravitational dance with their parent planets. If you somehow manage to find another body in space that harbors life, or potentially could, the universe offers a flood of opportunities. Now that we have laid out the material of huge degree, it's time to present the expert. Expert, arranged to paint its multifaceted details, the James Webb Space Telescope. This heavenly Sherlock Holmes, with its glorious central length displaced by movable focal points, outperforms even the most advanced Marfan optics. We're not discussing any lens. It's 6.5 meters in primary mirrors, 2.7 times larger than Hubble's. Imagine the best detail. It can detect even the smallest flicker of a star billions of light-years away, and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary isn't just its noticing power, but also its cutting-edge technology, including forward sensors and spectrographs. These instruments can do much more than observe. They can analyze and filter the special light signatures emitted or reflected by celestial objects to unravel their atmospheric conditions, composition, density, and even mass. Acting as a space detective, they can determine whether a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope has the ability to answer these questions, raising it from a simple eyewitness to a scientific genius. It's not just an evolution over its predecessor, Hubble, it's more like a quantum leap. If Hubble's discoveries amazed you, get ready for a genuine burst of celestial revelations. As we extend our view across the complex landscape of the universe, it's worth focusing on one specific star in the vast show, Proxima b. Since its discovery in 2016, this strange planet has stood out as a Shakespearean legend, filled with complexity and puzzles, captivating space experts and astrobiologists alike. What's the fuss about? First of all, Proxima b is basically in our astronomical neighborhood, just 4.2 light-years from Earth. To put it in perspective, if you could outperform the universal speed limit and travel at the speed of light, you would arrive in barely 4 years, about the same amount of time it takes for your favorite TV show to fall into reruns. But let's dig further into why this proximity is so significant. We're talking about a universe that expands over 93 billion light-years from one end to the next. So finding a planet so close and so promising for scientific exploration is like finding a diamond in a pile the size of Mount Everest. A gem that perhaps holds secrets about life itself in the grand woven fabric of the universe. Proxima b is a multifaceted line, offering us extremely valuable clues that could redefine how we may understand habitability and life beyond Earth. It's not just Proxima b's proximity to Earth that excites mainstream scientists, but also the enticing signs that this planet isn't just Earth-like, but maybe even Earth 2.0. Proxima b sits snugly in what space specialists call the habitable zone of its parent star, where conditions are neither too hot nor too cold, but just right for liquid water to exist. Imagine waterfalls, wandering streams, vast lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. But before we start dreaming about going to Proxima b, we need to consider some of the quirks. For instance, a single day on this charming exoplanet lasts an astounding 11 days. Imagine sunsets that stretch into another day, slowly resisting giving way to noon, and dusk that stretches, making brilliant hours that photographers dream of. While it sounds idyllic, it also has major implications for its environment and habitability. How would human biorhythms adjust to the patterns of light and dark on Proxima b? Would we need to eat 3 or more times in a single day on that planet? Would we sleep the same way on this totally different world? The key elements of life as we know it would be tantalizingly similar and yet tragically strange. It's like nature is giving us a puzzle wrapped in a mystery, testing our understanding of what makes a planet livable. You might wonder how we can get accurate and reliable data about a world we have never visited. The James Webb Space Telescope brings all its capacities like a giant Swiss Army knife. It's more than just a telescope, it's a sophisticated research lab in the vacuum of space. Thanks to its cutting-edge technology, space specialists can not only observe planets but also examine them through a prism of scientific instruments that would make CSI labs look simple. Using advanced spectrographs, the Webb telescope can analyze the light emitted and reflected by these distant planets. Each element or molecule in a planet's atmosphere absorbs or emits light at a specific frequency. By focusing on these patterns, specialists can perform a remote biopsy of celestial bodies, determining not just atmospheric pressure and density, but also the possible presence of compounds essential for life, like water, organic carbon molecules, and even oxygen. It's not just cosmology, it's space forensics. We don't passively wait for signs to come to us. We actively search them out, analyzing the atoms and molecules that make up these intricate worlds. The Webb telescope isn't just an eye in the sky. It's a highly specialized research facility, expert, and celestial detective all in one. It allows us to turn our hypotheses and theories about alien worlds into strategies to confirm or disprove them, revolutionizing our understanding of what could exist beyond our blue dot. Just when you thought you had uncovered the most astounding layers of this vast cosmic tapestry, the adventure is just beginning. As we stand on the verge of infinite discovery, the James Webb Space Telescope represents a map of hope and progress. Its powerful instruments are designed to delve into the most intricate details of distant worlds, revealing aspects of the universe that were previously beyond our comprehension. The JWST's capacity to analyze exoplanet atmospheres expands our journey into the farthest corners of space, providing insights not only into whether these planets could support life, but also how life could emerge under different conditions. One especially fascinating part of this investigation is the potential to detect biosignatures in the atmospheres of exoplanets. These biosignatures, such as specific atmospheric gases or chemical compositions, can serve as signs of biological processes. For example, detecting a mix of gases that includes methane and oxygen could suggest biological activity, as these substances often result from life processes on Earth. The JWST's advanced spectrographs can identify these subtle signs amid the vastness of space, offering a new window into the potential for life beyond our solar system. Moreover, The search for exoplanets has introduced us to a variety of planetary systems with unique characteristics. Some exoplanets have been found in binary star systems, where two stars orbit each other, creating complex gravitational conditions. Others orbit red dwarf stars, which are cooler and less luminous than our Sun, but potentially capable of hosting habitable zones.